All right, well, we can get started with the introduction just because we do only have an hour here. So welcome everybody. If you're just joining us, thanks a lot for joining us for this webinar on using Ipum's data in R with Ipumsr. We do only have an hour and we want to leave time for questions at the end. So this will be a bit of a whirlwind tour of some of the key features of Ipumsr. And our goal here is to really get you excited about about analyzing Ipum's data with Ipumsr, and then to point you to additional resources that you can explore on your own, including the files for this presentation. And as you use Ipumsr, you're bound to have questions. So at the end, we're going to provide links to a few places where you can seek help, including by reaching out to our excellent Ipums user support team or posting a question on the Ipums user forum. So we're going to be sharing the webinar recording and the slides and all the code that you see here. So there's no need to frantically jot down notes during the webinar. You should, however, type any questions in the Q&A as they occur to you. And our user support expert, Grace, or some of the other of us panelists will either answer them or add them to a list to be answered at the end. So finally, I just want to acknowledge that the Ipumsr package was created by Greg Friedman Ellis, and this webinar is actually based on a presentation that Greg created. So thanks to Greg for creating a great package and for letting us use the slides. And then also acknowledgements to the user support team. Thanks a lot for having this idea and setting everything up. So with that, we'll get started by briefly introducing ourselves, and you'll primarily be hearing from me and from Dan, but the development of the webinar was a collaborative effort between Dan, Kara, and myself. So first, who am I? My name's Derek Burke. I use he, him pronouns, and I've been working on the Ipum's international team for the past 4 years, and my academic training is in sociology.
Hi, my name is Dan Ehrlich. I've been working at IPUMS for just about 8 months now with IPUMS International. My background is in anthropology and archaeology, and I use he, him pronouns.
Hi, everyone. I'm Kara Fisher. I use they, them pronouns. I've been working with IPUMS for about 2 years, and my training is in public health and biostatistics.
And since most of us have our videos off today, we figured it would be nice for you to have a face to associate with our voices. So we've included all our pets. So in this presentation, I'm going to be covering a little bit of background of what IPUMS is. Hopefully you're a little familiar with IPUMS if you're here, but maybe you don't know all the resources that we have. Then I'll talk a little bit about what the Ipumsr package itself is. We'll cover reading data into R using the Ipumsr package, as well as exploring and manipulating the metadata, which is one of the biggest values of the Ipums data set. We'll cover a brief analysis example, as well as working with some geographic data, the GIS shapefiles that we have. And finally, we'll preview the Ipums API functionality. And then we'll have a little bit of time at the end for a Q&A, like Derek said. So to start out, what is Ipums? Hopefully you know that Ipums is data from censuses and surveys around the world, integrated across time and space, and thoroughly documented, freely available to researchers like yourselves at ipums.org. So, quick poll for everyone. Which data collections have you used? Ipums started as a single data project, and it's now actually comprised of 9 different collections. So we have a poll for the users that are here live and interactively, listing the 9 Ipums data collections: USA, Ipums CPS, Ipums International, Ipums Global Health, which comprises DHS and PMA surveys, NHGIS, IHGIS, time use, health surveys, or higher ed. So we're curious to hear and see what you use. And it looks like the majority of users here are using the USA data set, but CPS, International, and NHGIS are represented up there as well. Looks like we have some users of just about every data collection as well, though, so that's good to see. If you aren't familiar with some of these, hopefully you'll learn something new and get excited about some of this data. So just a brief background on our data collections. IPUMS USA. This was kind of the first data collection that IPUMS started with, and it contains full count census data from the historical 1850 census through the 1940s, and then 10% sample census data for more modern censuses, as well as supplemental data with yearly surveys to complement the census, the 10-year censuses. IPUMS CPS focuses, it's a more frequent survey, targeted monthly labor force surveys within the US. IPUMS International contains predominantly census data from 102 countries, as well as labor force surveys, which we are just starting to add in and release. We currently have two series of labor force surveys for countries released, and we are working on hopefully getting Mexico released later this year. IPUMS Global Health comprises the DHS and EMA health surveys. And one of our colleagues at IPUMS, Matt Gunther, has a blog where they demo some cool basic analyses and data visualizations using the IPUMS Global Health data. So you can check that out on their GitHub page here, which is also linked on their main ipums.org website as well. Health surveys focuses on the US again, and also has supplemental data on cost of healthcare in more recent years, as well as these two major domestic surveys. IPUMS Higher Ed tracks STEM outcomes and students. And IPUMS Time Use has some really interesting data, extensive time diary from individuals in the US and 700 countries. There's some really cool visualizations that I've seen online that people do with how people use their time. Finally, our NHGIS is summary information and data. That summary information is combined with GIS shapefiles. And NHGIS actually has shapefiles for all levels of US geography down to census tracts, which is the smallest individual geographic unit of analysis used in the census. And IHGIS similarly has summary data from several countries around the world integrated with GIS shapefiles. So that was a bit of a whirlwind presentation of some of the data we have here. And we're now wondering of all of these which you're most excited to start using in the future. So I think we should have another poll on the screen now. Great. So which, again, of the IPUMS data collections, which ones are you most excited to use? Even if maybe you didn't know about it before, and what kind of data are you excited to start working with? Hopefully with Ipumsr. And so the results are in. It looks like people are still pretty excited about the IPUMS USA collection. Makes sense. And it also looks like a lot of people are interested in learning more and using the NHGIS data collection. GIS and GIS-based analyses are definitely a cool feature, and Ipumsr does have that built-in support to work with shapefiles using two different R packages that we'll talk about in just a little bit. So glad to hear that there is a lot of interest in all of these IPUMS collections, it seems. So in summary, IPUMS is a lot of data, and what unites these different data collections and projects is the consistently documented metadata. That metadata provides a lot of context, as we'll see later on, that really allows you to better understand all that data, the ones and zeros that you're working with, and really understand what it means in a kind of societal context. And I know what everyone's saying to themselves right now. How can I get my hands on this data? What's the best way to interact with IPUMS data? Well, the answer is Ipumsr. So like Derek mentioned, this package was developed by Greg Freeman-Ellis and released in 2017 on CRAN. It has well over 90,000 downloads at this point. And it includes several features. First and foremost, reading in your data from IPUMS. With so much data and so many different types and levels of data to work with, you can imagine if you would need several different programs or several different scripts to really work with all the different types of data that you might be able to access from IPUMS. And so especially working with that metadata, we'll see how that can add a lot of flexibility and interesting information to your analysis. And towards the end, Derek's going to demo interacting with the IPUMS API. That feature is not released yet, but it is coming soon. So why use Ipumsr? Well, it's, as I said, one package that allows you to work with the microdata, the aggregate data, the GIS shapefiles all together. So you might say it's one package to rule them all 9 different IPUMS data collections. And it also has some specialized functions for viewing and manipulating IPUMS metadata. We also have some built-in vignettes that come with the R package. These are kind of detailed tutorials that demo several key features, such as working with GIS shapefiles in R and with IPUMS, working with big data by using both chunk and yield options, and reading your data, working with several kinds of IPUMS data extracts and getting them into your R environment. And maybe the biggest reason to use the Ipumsr package is that we are actively working on it and we want to make it work for you. So if you have ideas for new features like the API support, email us or start a thread on GitHub and let us know, and we will be happy to get working on that. We are really excited for people to interact with the IPUMS data collections using the Ipumsr package, and if there's anything we can do to make that easier for you, that's what we're here for. And finally, why use the Ipumsr package? Well, it's pretty fast. When you're dealing with millions and millions of individuals and possible variables, the time it takes to read that data in might add up. And if you're trying to interact with both the raw data and the metadata, IPUMS is definitely your best option. So we have another poll for the group. We're wondering if anyone has actually used the Ipumsr package before, or if you're all here as first-time users, excited to hear more. So the options for the users here today are: no, you've never used it; yes, you've used it a little; or yes, you've used it a lot. All right, so it sounds like, or clearly looks like, most users, over 80%, have never used the Ipumsr package before, and we're excited to have you here to find out more about it. A couple users, though, have used it, and some have even used it a lot, and that's cool too. So at this point, we'll just cover the basics of how you can get your hands on installing the Ipumsr package. And since it's on CRAN, it's actually super simple. You can just use the install.packages command, and that will download it directly from the CRAN repository. If you're feeling like the basic version, CRAN release is a little too stable for you, you can check out the development version by downloading it directly from our GitHub. If you don't have the remotes R package, that just allows R to connect to external sources like GitHub. So this first line of code will install the remotes package, and the second line calls on the remotes package to install Ipumsr from our public GitHub repository. The code used in this webinar is available on our GitHub repository, so you can feel free to clone and download that locally for yourselves. And outside of the Ipumsr package itself, the code we're using in this webinar is going to use a few other R packages. First and foremost is a few packages from tidyverse, such as dplyr. We're going to also use ggplot and stringer for some data management and per as well to clean up our data. For some of the formatting in this presentation, we're using the DT package, and we're working with the GIS shapefiles later on. We're using the SF package. So if you need any of those packages, you might want to install them beforehand. And then as you're working interactively, you just need to make the library calls to make sure that they are in your local environment to use those functions. So that's it for the background on IPUMS and Ipumsr. Hope you've enjoyed this whirlwind tour. I'll now pass it over to Kara to handle reading data into R.
Sorry, Dan. Actually, I'm going to be doing this section. Sorry for the miscommunication, everybody.
I'll now pass it over to Derek.
Yeah.
Who will be covering reading data into R.
So, and can you see my screen, Dan? Just a test.
Yes. Let's hear
Okay, great. Okay, so yeah, let's talk about reading your data in. So one of the things that's a little bit tricky that can trip some new users up is that to download your data extract, you actually have to download both the data file and this DDI codebook file. So this shows a screenshot of what your downloads page looks like on the website. And first you need to click the download.dat button or link and save that data file. Then you have to right click that DDI link, and that'll bring up the right click menu. And depending on the browser that you're using, on Firefox and Chrome, it'll be an option called like save link as is what you'll want. If you're using Safari, you'll want to choose download linked file. And you just want to make sure when you save that file that it's a .xml file, because especially on Safari, that can be confusing. If you download an HTML file, then this won't work. So that's the first key thing, is to remember to download both the data and the DDI codebook file. And it's easiest if you save both of these files in the same folder. And in case you're wondering, the DDI just stands for Data Documentation Initiative. So it's a standard, an international standard for documenting data sets that IPUMS follows in a lot of its codebooks. So we might refer to the codebook or the DDI kind of interchangeably. So the second thing that's optional is there's an R link on your downloads page. This was a little newer. And you can click this to see some helper code that we're going to show in just a second. That basically just reminds you how to read in your file once you've downloaded, how to read in your data once you've downloaded the data and DDI files. So once you've done that, you've downloaded your data file and your DDI codebook and saved them in the same folder. Here's how you actually read the data into R. This is the recommended workflow. So you read the DDI file with read Ipums DDI, pointing to that XML DDI file, and save it to an object called DDI. Then you pass that object to the read Ipums micro function, and then you assign that to whatever you want to call your data. And now you actually have the data in your workspace. You also can just point directly to the DDI codebook file with the read Ipums micro function. This will also work to get the data in. But we recommend the first workflow because it's often nice to have that DDI object in your workspace. Once you start messing around with the data itself, you might lose some of the attached metadata, and the DDI will preserve all that metadata in case you need to reference it again. So this is another confusing thing, potentially confusing thing. So you need to download the data file and the DDI file, but it might be confusing as to why you're pointing to the codebook file, this DDI codebook file, and not the data file itself to read in the data with Read Ipums Micro. So we want to dwell on this for a second. Why do I point to the codebook to read in the data? And my attempt to explain this in a hopefully memorable way is that the data file is dumb, whereas the codebook is smart. So what do I mean by that? So here's a view of the first 10 lines of the data file, that example data file we're using for this presentation. So looking at this, you can kind of see why you can't just say to R, read this data file in as a data frame with meaningful variables, because there's no information in here about which variables are in which columns, what the values mean, or any of that information. So in case you're wondering what those blanks are that we're seeing, that's actually a geography variable that's not available in all the years in our data set, in case that looks confusing. But so the data file is kind of dumb. The DDI codebook, on the other hand, is smart. It has a lot of information that you see here. So here are the named elements of that DDI object. In particular, it has the file name of the data file. So if you save those files in the same directory as we recommend in the same folder, that's why you can just point to the DDI, and that will tell R where that data file is, and you don't actually have to specify that explicitly. The other thing that's really important in the DDI is this var info object. So let's look at that. That's actually just a data frame itself, or a tibble. And each row in that object has all this information about each of these variables. It has the variable name, the label, the description, the value labels, and then important for reading in the data, it has the start and end position, which columns correspond to that variable in that fixed width data file. Okay, so that's how you read in your data. Next, we're going to look at exploring and manipulating metadata. So we've read in the data, but how do we figure out what's in the data if we forgot or we want to learn more about it? Maybe I wrote an informative extract description here when I created the extract. Well, it doesn't look like it. I wrote revision of my extract. So that's not very informative. And any other longer time Ipums users might recognize this. This is what happens if you revise your extract repeatedly and don't specify a new name. So no such luck here. We can just print the names of our variables like you can do with any data frame, but often the variable names themselves aren't self-explanatory. So let's leverage that attached metadata that we've been talking about. So here's some of the available metadata, and there's helper functions in Ipumsr to access this. So the variable labels and descriptions can be accessed with Ipums var label and Ipums var desc. And here we're pointing to the DDI and then specifying which variable we want. You can also point directly to the column in the data set, as we'll see below. So phone is telephone availability, and the longer description says phone indicates whether residents of the housing unit had telephone access. So that's a little bit better than just the name itself. We can also print out the value labels with this Ipums val labels helper function. And we see from that that the variable phone takes 4 values, 0, 1, 2, and 8. And the labels for those, NA, no, yes, and then suppressed. A really nice interactive view of the metadata is also available with the Ipums view function. So this is one that I really want to promote. I think it's a really nice way to browse what's in your data set. You point to the DDI here, and then it generates this static HTML page that you can scroll through, and you can click this plus symbol to collapse or uncollapse any given variable and see the description and the value labels. So that's a really nice option as well. Okay, so now let's talk about what you can do with these value labels, like if you want to recode the variables. So this is another potential stumbling block. IPUMS value labels don't translate perfectly to any base R data type. They're close to factors. They're similar to factors, but every value in a factor must be labeled, whereas IPUMS variables sometimes only have a certain values that are labeled, like a top code or a missing value, and like an income variable or a quantitative variable. And then perhaps most importantly is that factor values always count up from 1. So they have labels, but the values are kind of meaningless besides the order. Whereas IPUMS variables often have meaningful values that encode like a hierarchical structure, like what we'll see with the education variable in just a minute here. So to preserve the values and labels, the Ipumsr package reads these labeled variables in as Haven labeled objects. And that preserves that information, but because these aren't base R objects, they can be a little tricky to work with because other packages might not support them. They might strip away those values and labels when you use an operation on them. And base R functions don't always support them. So the Ipumsr helper functions allow you to leverage the info from the values and labels and transform these Haven labeled objects into like a factor or a regular numeric or character vector so that you can use it in your analysis. But you can reference the values and labels to recode the variable in the way that you want it. So let me just take a look at what these Haven labeled objects look like when you print them out. So you can see here, not all of these are labeled variables, but the first one we see here is state FIP. So this is the first clue that it's labeled. It says it's an integer plus label, and then we get the value, and then in square brackets we also get the label when we print it out. So this is like right after we read in the data and you print it out, this is what you'd see. So if we do, there are kind of at least two sort of nuclear options if you just don't want these labeled objects at all. You can use the as factor function to get rid of these columns. You can pass the whole data set to this function and it will selectively convert just the Haven labeled columns to factors. And so what happens then is just that you only get the labels themselves. So we don't see the 27 for Minnesota anymore. We just see Minnesota. We don't see these values, and like the education variable, all we see are the labels as factor levels. Another option, if you just want the numeric values that are part of these Haven labeled columns, you can use this zap labels function. And you can see here now we just have the numeric code and not the label. So hopefully we can convince you that that this isn't always the best option, because Ipumsr provides these label helper functions that allow you to be a little bit smarter with how you recode these variables to fit your analysis. And there is a bit of a learning curve, I think, with some of these functions, but just like any new type of function, I think the work pays off if you put the work in. So let's see here. So yeah, there might take some trial and error, but I think it's worth it. So the first one we're going to look at is LabelNF, and all these functions start with this LBL underscore prefix. So this one, LabelNF, allows you to recode certain values to NA, which is R's missing value, according to either the value or the label. So here's another view of the value labels for the variable phone. This time we're pointing to the actual column in the data frame. And that's another way to print out those labels, as long as it's still a Haven labeled column. So looking at these values in the labels, it looks like the values 0 and 8 could really be recoded to missing, because they're not really providing any information about access to a phone. So here's how we do that with LabelNF. So LabelNF and these helper functions support a special syntax that we see here. for referring to the value and the label of the original variable. So I use the .val variable to refer to the value of the variable, and the .lbl or .label variable to refer to the label. And so here, this basically can be read as create a new variable called phone2 by recoding variable phone to NA or to missing if the value of phone is 0 or 8. And then after that, we can convert it to a factor now that we've recoded it the way that we want. So this table below shows the result of that. The 0 NA and the 8 suppressed have been recoded to missing, and so they show up as blank. And notice here, I think this is a useful pattern to create a new variable when you're trying to recode your original variable. That way, if it doesn't come out right the first time, you can try again, and you won't lose that original variable. So if you're unfamiliar with this anonymous function syntax that uses the tilde, this little squiggly line, basically this is the same as this. So it's saying apply a function of .val and .label to this variable and return whether the value is in 0 or 8. So it will return a true value, a value of true for those values that are 0 or 8. So this is just another way of putting that, but this is more concise, and I think it's worth it. Once you get used to it, it'll be a lot quicker way to write your code. So LabelNF works with both the .val and .label special variables. So to do accomplish the same thing, we could create a vector here of the actual labels that we want to recode to missing. And now we've created a phone3 variable that just says phone3 is a new variable where we recode phone to missing if the label is in one of these dropped labels here. So that's LabelNAF. Another one is label collapse. That allows you to take advantage of the hierarchical structure of IPUMS value labels. So the education variable here has this hierarchical structure where values between 0 and 9 are all NA or no schooling. Values between 10 and 19 are all different levels of detail of nursery school to grade 4. And so maybe this is too much detail for your analysis. Like if you want to do a visualization, this might be too many education categories to display in a visualization. So how do we collapse that down? In this case, we just want to collapse the last digit. And so we're using this integer division operator, which is the %/%. And basically that can be read as how many times does 10 go into value? So if we have the values down here, 0, 1, and 2, how many times does 10 go into 0? It goes into it 0 times. How many times does 10 go into 1? 0 times. And so 0, 1, and 2 will all return a value of 0, and that's why they'll get collapsed into one value. And label collapse takes the label from the smallest collapsed value. So if all of these 3 get collapsed into 1, they'll all come out with the label from the smallest value, which is NA or no schooling. So that's why we see here 0, 1, and 2 come out as NA or no schooling. And then values like 11 through 17 all come out as nursery school to grade 4, etc. And like I said, I think these functions, I wouldn't be discouraged if this isn't immediately clear what's going on here, but I think they show kind of how you can do something pretty complex with a concise syntax. So also I want to highlight that there is this argument to as factor ordered equals true that you can use if you want to preserve the order. So in this case, it makes sense because education is kind of an ordered variable, levels of education. So you might want to use that in some cases. But maybe that's still too detailed for a graph. So this is the result of the previous slide, printing out the value labels. And we see we still have like 13 values, and that still might be too detailed for a visualization like what we're going to do below. So that's where this function label relabel comes in. So this is like the Swiss Army knife of the label helper functions, because it kind of gives you full power and flexibility to create an arbitrary number of new labeled values, controlling both the resulting value and the label, and still using that special .val and .label syntax to refer to values and labels. So this obviously is not immediately clear what's going on here if you've never seen this. So let's walk through this a little bit. So the first line here just creates a regular expression that's going to match 1, 2, or 3 years of college, and we'll use that below. So that just makes this line a little bit shorter here. Then the first part of the piped expression just performs the same collapse that we did before, so that after we do the collapse, we get these values and labels that we showed on the previous slide. So this is the input to label relabel, is this already collapsed version of the variable. So then from there, each of these lines within the call to label relabel creates a new labeled value, and this specifies the value and then the label. So like this line here, hopefully you can see the highlighting. The first line in the label relabel call can be read as assign a value of 2 with a label of less than high school when the input value is greater than 0 and less than 6. So looking here at the input, 0 to or greater than 0 and less than 6 is values 1 through 5, and all of those are going to go to less than high school, because value 6 is grade 12, which would mean that somebody probably graduated from high school. So that's kind of how you'd read that. And then also I want to highlight that we've got examples here of the .val syntax on the first line and the fourth line here. But then we also have the .label syntax on the second and third lines. And the third line, for example, can be read as assign a value of 4 and with a label of some college when the input label, so we're referring to the .label, when the input label matches with string detect, matches that pattern that we defined up above. So that's why these values, 1, 2, 3 years of college, these labels will all match that pattern. And so then they'll receive a value of 4 and a label of some college. Okay, so now the result of that is that we have only 6 values in our resulting factor. We did coerce to as factor at the end there. And so this is a more simplified version of the education variable that might be more suitable for visualization, or depending on your analysis, it might be what you want for your analysis. So there's obviously a lot to explore here. I would encourage you, if you want to learn more, to check out the value labels vignette, and we'll provide a link to where those vignettes live at the bottom here. So let's quickly look at a brief analysis example. So now that we've converted to factors, we can use them kind of as regular R data. So here we're summarizing by year and creating a summary percentage of people with phone in each year using that phone to variable that we created. And we had set the 0 and 8 to missing values, so those will be excluded by using this option. And then we can use geom_point and geom_line from ggplot to create a nice plot here of access to phone over time. So you might look at this graph and say, what the heck is going on here? Why would access to a phone line decline in the mid to late 2000s and then all of a sudden come back? So what's going on here? The answer we can find actually on the comparability page on the IPUMS USA website. So this is available for all harmonized IPUMS variables, this comparability tab on the website. And we see here in the highlighted text at the bottom that the 2008 ACS and PRCS told respondents to include cell phone service when they answered this question, but before 2008, this wasn't made explicit. So people started saying, no, I don't have access to a phone. before 2008 because they thought they only were referring to landlines. So that's just one small example of kind of the value added by the work that Ipums does to figure out these comparability issues and to document them. And then we can use that education variable that we worked on to provide a kind of not too busy visualization of access to a phone line by level of education. And we can see here kind of the main takeaway from these plots, I would say, is that educational differences in access to a phone have declined over time from 1960, where in 1960, people with less education were significantly less likely to have access to a phone. And now it's kind of the same at all these different education levels. So, okay, and we're going to go pretty briefly through the geographic data section because we're a little low on time, but also there's a vignette on working with geographic data that we'll point to. So if you want to learn more, definitely check that out. So we do provide geographic data with several of our microdata projects. Here we're going to be using ConsPUMA, consistent public use microdata areas. That's a variable with Ipums USA that facilitates analysis over time. I should note that these units are pretty large, as you'll see in the map below. If you want more detail, check out Ipums NHGIS, which has tabular data with shapefiles and has finer geographic detail. So the first key question is, where do you get these geographic shapefiles? You don't get them as part of your extract, except for with NHGIS. And so you've got to go to the homepage of the project, like Ipums USA, look on the left side, and you'll see a link for geography and GIS. And that's where you can download the shapefile in a zip archive and unzip it, unzip all the contents into a one directory. And once you've done that, so here we've done that to a directory called shape, we can use the read Ipums SF function to load that into an SF data object, which we'll show in a second. If you want to learn more about like SF versus SP packages, I would definitely encourage you to check out the book, free online book, Geocomputation with R, and we'll provide a link to that at the end as well. But so we read in the shape data. Basically, that's just a regular tabular data frame with a special geometry column. And I feel like that makes it a little easier to understand what's going on when you merge the data to this shape data. So really, it's just a table with a special shape column. So Ipumsr also provides helpers for working with for merging these data. But first, you do need to summarize the person level data up to the level of the geography that you want to merge with. So here we're summarizing to the ConsPUMA and year level with that same variable, creating that same variable, percentage of people with access to a phone by ConsPUMA and year. And then we join here to the shape data. And we get these messages about dropped observations because our microdata only includes people from Minnesota to keep it as a small example data set. And so all the ConsPUMA units that are not in Minnesota get dropped out here. And with the addition of the geom SF function in ggplot, it's easier to make a graph, a ggplot graph with those data. So there's a code, and then you get a nice plot that again shows declining variation in access to a phone line, this time by geography in Minnesota. And you can see like one of these ConsPUMA units is like most of the state. So it's not the finest geographic detail, but it serves for example purposes. Okay, finally, we want to get to a preview of Ipums API functionality. So this functionality is not available yet, but here's a little bit about the timeline. We're currently in internal testing, and we hope to do, we're going to be doing beta testing before the end of the year. If you are interested in being a beta tester, you can reach out to us and we'll add you to the list. That's not happening yet, but we'll certainly add you to the list and let you know when we are doing that. And then Ipums USA is going to have a public launch for the API in early months of next year. And we are doing it one project at a time, one data collection at a time, so that we can test it for each data project. Another important API related note is that IPUMS NHGIS, which is not microdata, tabular data, already has a public API, and we have documentation on how to use that with R. It's not, we don't have tools for that in Ipumsr, in the Ipumsr package yet, but we're planning to add that sometime next year. So, but you can already use it in R, and we have documentation. So what can you do with the API? This is like an overview of the features. You can define and submit extract requests. You can check your status of your extract or wait for the extract to finish. Excuse me. You can download your completed extracts, and you can get information on past extracts, including the ability to pull down the definition of a previous extract and revise it and submit it again. And then finally, we're really excited about the ability to share your extract definition, and you can do that as a JSON file, which means that other users who aren't using R will also be able to kind of ingest that definition and create an extract that matches those specs themselves. So a few limitations. You're still using the extract system, so you don't get data on demand. So you still have to wait for your extract to process. You can't yet explore what data are available, but we do plan to add a metadata API in the future. And you can't use all the features of the extract system right away. You can't, for example, attach characteristics of family members like you can do with an extract on the website. But we will plan to add those once the core functionality is more stable. Okay, so let's get to some example code. This is what using the extract API is going to look like, at least right now. First, we define an extract by using the define extract function. That's going to be part of the package. We specify the data collection, USA, the description of the extract, occupation by sex and age. Here we're asking for the 2017 and 2018 ACS, that's the samples here. And then the last line, we're requesting the variables sex, age, industry, and occupation. So we create that definition, save it to this object, and then we can go from an extract definition to having the data right in our R session in just one piped expression. So if you're not familiar with this pipe operator, you can read it as then. It's from the Magritte R package, or also dplyr. So you can read this as take my extract, then submit extract, then wait for extract, then download extract, then use read IPUMS micro to read in the data. And you can also use the new base R pipe. So this just shows the different pipe that's available as of R version 4.1, and that will work as well. So here's what that would look like in terms of the messages you get when you're waiting for your extract. You get a message when you submit that it was successfully submitted, and then wait for extract, checks the extract status, and then waits for a little while, and it doubles the waiting time each time up to a limit, a maximum of like 5 minutes, which you can configure until the extract is ready. So then you get a message, extract ready to download, and then download extract prints out this message about where it saved the codebook file and the data file. Another workflow that might be of interest to people is getting the definition of your is revising and resubmitting a previous extract. So here you can get the definition of your most recent extract with this function, or if you know the extract number, you can use this shorthand that Greg Friedman Ellis actually suggested, which I really like as a way to grab the definition for USA extract number 33. So now we've saved that definition to this object called old extract. And then in this example, we can add one variable that we forgot to add. We say old extract, take old extract, then revise extract by adding the variable education, and then submit it again. So finally, the final kind of feature I want to show off is the ability to share your extract definition. And currently the way that you would do that is to use this function, save extract as JSON, it would take that my extract object and save it out in JSON format to this file. And that makes it easy for somebody who may not be using R to take that JSON, read it back in, and submit the extract for themselves. But if they are using R, they can use the kind of paired function to read that back in, define extract from JSON, and point to that extract file, the JSON file, and supply the corresponding data collection. And then that cloned extract will look exactly like that original my extract object. Okay, so hopefully we've left time for some questions now. I know that was a whirlwind tour of IPUMS projects and of Ipumsr. We hope you have some questions that we can answer. And I'll put up the resources slide here during the Q&A.
Hi, Derek. Yeah, we do have quite a few questions. I guess I'll start. A lot of people were asking about accessing the resources that you've posted there. Will the slides that you've shown be made available to users as well?
Yes, so those will be on this GitHub, and we'll share that link after the fact as well. We will share, and we can also share a PDF version of the slides. These are HTML, but all the code used to create the slides will be in this repository as well.
All right, and then also some questions about when, and sorry if I missed it, but when the API will be made available?
Yes, good question. So it's not, we don't have a fixed date. We're going to be doing beta testing in the last few months of this year. And depending on how many issues come up, I think certainly in the early part of next year, hopefully in the first couple months of 2022, that'll be available to all IPUMS USA users.
Oh, great. So we had some questions about using weights. Are there resources about how to incorporate weights in Ipumsr?
Yeah, that's a really good question. That's something that I think we need to, there's been interest in that before. And when we talk about, like Dan highlighted the fact that the Ipumsr package is kind of a place for our users who use IPUMS data to ask for features like that. And so there's not really resources, but we could create like at least a vignette and then possibly some functionality that does some of that work for you in terms of making sure that you're using the weights properly. I would definitely recommend another package that actually Greg Friedman Ellis created, the SurveyR package, SRVYR, that allows you to use kind of a dplyr syntax with the survey package, which is kind of like the gold standard for working with survey data in R. So both of those packages I would recommend.
Okay, and then to piggyback on that, what about working with replicate weights to estimate standard errors?
Okay, so yeah, that's something I would say. So we don't have that like bundled with the package, but that's definitely something we'd be interested in answering questions about, and then like including that in a vignette on working with weights, or if there's an opportunity to even create some functions that make that easier. That's the kind of feedback that we'd love to get from our users, either by, you can email this address, which will go to user support and to the team that manages the Ipumsr package, or post on the user forum, even create an issue on GitHub, which I know some users have done. And then we can start a conversation about how best to help you out.
Okay, another user is wondering, what is the best way to ensure your IPUMS USA request is saved? So like the variables and samples, I guess like information about their extracts.
Okay, I guess, well, I know that all of those, if you create an extract through the website, that the definition of that extract will be saved on that My Data page. So even if the files themselves aren't accessible anymore, then you can go back and recreate that. But is that your understanding of the question, Grace?
Yes, I believe so.
Okay, and then same thing with the API once that's available. As long as you know the extract number and the data collection, you can always retrieve the definition of a past extract, in case you forgot exactly what was included in that, or you lost the file that you downloaded when you first created the extract. But yeah, so hopefully that's helpful. But definitely, if there's more questions on that topic, follow up with us.
Okay, another person asked, what does Ipumsr convert the value labels to? Is it Haven labeled, SJ labeled?
Yeah, so I think I guess I'm not necessarily familiar with the second option there, but yeah, everything, any labeled variable when you read it in will be by default stored as a Haven labeled object. So yeah, if there's other options out there, I mean, that would be a pretty big change. So that would be something that we'd have to um, take into consideration. But if there's other options out there that people know about for how to preserve that value and label information that we're doing with Haven labeled, definitely reach out to us, and we can explore that possibility. But we do currently just use the Haven labeled objects.
Is there a resource to merge Ipum's data in R from different data sets by geography to the county level?
Yes, I know with between IPUMS projects, like IPUMS DHS and IPUMS International, definitely provide crosswalks. They're called, between those like geographies. Um, I would definitely check out the geography and GIS page of the project that you're interested in. So we showed that. Let's see if I can get to that. Like for Ipum's USA. Oops, I went too far. Sorry. Um, for Ipum's USA, that's here. So this where this arrow is pointing here. Definitely check that out, because in addition to shapefiles, that also just has a lot of documentation about our geographic variables. So I think that would be the place that you'd find guidance about merging like to other data sets based on geography.
I know we're sort of out of time, but there are several more questions. I don't know how many more should we take, Derek?
Well, we could go to 11:05 at least, I think.
Okay. Can we download the data directly to a server?
Ooh, yeah, well, actually, yeah, you can. I don't understand all the implications of that question, I don't think, but I know like internally in internal testing, um, with the API, you'll have that ability. Like if you're running your R code on some server, that our session can download the data onto that server. And yeah, so in that way, I think the answer is yes. But again, I think there might be more to that question that I'm not getting at. So definitely, if there's follow-ups, let us know. And I should say, like you said, Grace, we can't get to all of them, but we are planning to answer all the questions that you've submitted in writing, and we'll send that to all the attendees after the fact once we write those up.
Right, that's a good point. Another one, is it possible to download the DDI for previously downloaded extracts that are no longer available?
That's a really good question. I think the answer is no, that you can't download the DDI without resubmitting the extract. But I could be wrong about that. I think it's no. I think you have to resubmit it, but it's not too much. Hopefully, it's not too much trouble to resubmit. And it only, like in testing. So I've been testing the API, and like even fairly large extracts maybe take like under 30 minutes to process. At least in my testing, it can vary a lot depending on traffic, but um, yeah, I think you do have to resubmit it to get access to that DDI again.
Okay. I think maybe we could just do a couple more. Is there any code on the GitHub page regarding building the family into relationships?
Oh, okay. That's a really good question. That no, there isn't. That code is not easily available publicly in terms of. So I know from working on IPUMS International, have worked on that pointer code or the family interrelationship code, and I think we're still figuring out the best way that we can share that. We've made advances for our harmonized variables in general through the website. Now you can actually see the recoding that we do, the programming and like the what we call translation table recoding. You can see that for a lot of variables, but those family interrelationship variables are kind of an exception because of the complexity, the greater complexity of the programming involved. So I would say if you have a question about that, definitely it would be a situation where you'd want to reach out to user support or post on the forum, and we'll be able to try to answer your question that way. But the code itself is not easily accessible to the public.
Okay, I guess we can make this the last question. The label helper functions seem like they'd be useful with tidy census data too. Am I understanding that correctly?
Yeah, I think well, so they're helpful with they can be used with anything that's coming in as a Haven labeled object. So we also do have a function because a user requested it that uses the same syntax as those label helpers to actually create a new Haven labeled object. So kind of like that label relabel syntax where you can specify both the value and the label if you want to create a new one. So if tidy census, if that data doesn't come in as Haven labeled, you could use Ipumsr functions to like transform it into a labeled object, and then you could use those label helpers to manipulate that however you want. So, but if it is coming in as Haven labeled, then you can right out of the box use these Ipumsr functions to recode those variables.
Great, thanks.
Okay. Well, like I said, we will write up answers to all your questions that you've submitted through the Q&A. So thanks a lot for submitting those. And I would definitely encourage you. We really want to hear from you. If you have issues, we really want to help you out. So contact us by email or on the IPUMS forum or on the Ipumsr GitHub here. Definitely just, I hope this is like kind of the beginning of the conversation for some of you new users. So we're here to help. And thanks a lot for taking the time to join us this morning.